In the vast world of materials science, a quiet revolution is unfolding. At its heart lie metal organic frameworks, or simply MOFs, intricate crystalline structures built from metal ions and organic linkers. They are unlike anything scientists have ever designed, materials with tunable pores, record-breaking surface areas, and precisely tailored chemical functions. Each framework is like a molecular sponge, absorbing, separating, or transforming molecules with astonishing efficiency. Over the past few decades, researchers across the globe have synthesized more than 100,000 MOF structures. Yet, despite this scientific abundance, only a handful have found their way from the lab bench to the marketplace. Now, the story is shifting. The global MOF industry is standing at a defining crossroads, moving steadily from academic curiosity toward industrial reality. Analysts project an annual growth of nearly 30%, with revenues reaching hundreds of millions by 2035. What's driving this surge? The world's mounting challenges, from tightening environmental regulations and decarbonization efforts to growing water scarcity, and the unrelenting demand for cleaner, more efficient energy systems. Among all potential uses, carbon capture stands as the flagship frontier. Companies like Svante, Nuada, Mosaic Materials, and Aspira are pioneering MOF-based systems to trap carbon dioxide from the air and industrial exhaust. One breakthrough shines brightly: Svante's use of CAF20, a zinc-based MOF manufactured by BASF. This innovation has already captured 1 ton of CO2 a day from cement plant flue gas, a clear signal that MOF technologies are ready for real-world impact. But carbon isn't the only prize. Another arena, water harvesting and HVAC, is rapidly gaining attention. Companies such as Waha, AirJoule, and Transaera are harnessing MOF's remarkable ability to pull water directly from the air, even in arid deserts. In Death Valley, one of Earth's harshest environments, MOF 303, an aluminium-based framework, proved its power, producing nearly 0.7 liters of water per kilogram of MOF each day. Then comes the world of chemical separations. Traditional purification methods consume massive amounts of energy, but MOFs promise a leaner, cleaner alternative. Firms like Unisiv are showing how MOF-based membranes can separate gases such as propylene and propane with purity levels as high as 99.5%. Gas storage has already crossed the line into commercial success. NewMat Technologies Ion X cylinders safely store hazardous gases at subatmospheric pressures for the semiconductor industry, reducing risks and redefining standards for safe gas handling. Still, the road to mass adoption is far from smooth. Scaling production from gram-scale lab batches to ton-scale industrial output remains a formidable challenge. Manufacturing costs are still high, processing complex, and regulatory approval slow. Yet, each hurdle brings the industry closer to maturity. Today, around 50 companies worldwide are actively producing MOFs. Industry giants like BASF and innovators like NewMat are leading the charge, with capacities reaching into the hundreds of tons per year. Meanwhile, specialists such as Promethean Particles and Novamof are tailoring bespoke formulations for emerging markets. As production methods evolve and costs decline, the momentum is unmistakable. The convergence of environmental urgency, industrial innovation, and technological refinement is shaping a new materials revolution, one that mirrors the path once taken by semiconductors, polymers, and nanomaterials. The coming decade, from 2025 to 2035, promises a dramatic rise. Revenues are forecast to climb into the billions, powered by MOF's expanding role in carbon capture, water harvesting, gas storage, and chemical purification. The global market for metal organic frameworks 2025 to 2035 captures this transformation in vivid detail, tracing how MOFs are evolving from laboratory marvels into commercial mainstays. Through deep analysis of manufacturing methods, market forces, and real-world applications, the report unveils the pulse of an industry in transition. It charts production techniques, from solvothermal synthesis to mechanochemical routes, and assesses how each affects scalability and cost. It examines market segments across continents, from North America's industrial hubs to Asia's fast-growing technology corridors. It also highlights more than 40 key players shaping the future, from AirJoule and Aspiradak to ExxonMobil and Novamof AG. Every dataset, every forecast, tells the same story, of science crossing into industry, and innovation meeting necessity. With its unmatched porosity, sometimes exceeding 7,000 square meters per gram, and almost endless design flexibility, MOFs are no longer just materials. They're becoming instruments of change, capturing carbon, harvesting water, purifying gases, and enabling a cleaner, smarter, more sustainable world. Seedling emoji. And this is only the beginning. Discover how metal organic frameworks, MOFs, are transforming science into real-world impact. From capturing carbon and harvesting water in deserts to storing gases safely and purifying chemicals efficiently, these futuristic materials are reshaping industries. With thousands of designs and skyrocketing growth, MOFs are leading a new era of clean technology and sustainability.